Dear judges, I'm Matthew Lim, team leader of Aeroplover from Temasek Polytechnic, and in this presentation, I'm going to cover the introduction, the satellite solution, the paradigm used, specific details of the satellite, problems and solution with using the paradigm, mission operations, finance, and finally the conclusion. Deforestation is defined as the destruction of forests by people and is done either through logging or burning. There are several impacts for this. The economic impact is that it cost Singapore $50 million due to the haze in 2013. There's also the health impact, which affect the human's hearts and lungs, and also the natural impact, which is the loss of biodiversity and the contribution to global warming. Currently, forest rangers have to patrol around forested areas but have little situation awareness due to the vast areas they need to cover. The team also feels that unmanned aerial vehicles are impractical due to it being subjected to severe weather conditions. It also needs to cover vast areas and it generates a lot of noise as it flies along the forested regions. Now I shall pass the time to Aiman, who will tell you more about our solution. Aiman, please.
Thank you, Matthew. Now I'll be sharing to you our solution. Our solution is simple. We combine the constellation paradigm as well as the sensors that have been used from previous missions. Generally, for this project, we are using two types of sensor, the albedo sensor as well as the soil moisture sensor. You see, the problem that we are facing is that we often experience the consequences first, before having to realize that deforestation is occurring. For example, you won't know whether deforestation is occurring till you experience hazy weather conditions, climate change, or even soil erosion. To make this more clear, let me give you an analogy. If you don't go for regular checkups with a doctor, you won't know whether your body is functioning well. Having said that, why not we take this chance and prevent deforestation from occurring? Generally, these two sensors have the ability to track down the health conditions of the trees as well as the environment surrounds it. With the constellation paradigm, we are able to get high revisit time and we are able to locate spots that need attention accurately. The information will then be handed over to the authority. Next, I'll be sharing to you about the types of paradigm used. So what exactly is constellation satellites? Constellation satellites are basically a group of satellites working together for a specific mission, not forgetting a group ground coverage. Examples of constellation satellites includes GPS, also known as Global Positioning System. Galileo also uses similar concepts. Since we are using constellation satellites, 16 satellites will be spread out evenly and be placed 350 kilometers above Earth. We have to ensure that the distance between each satellites are far enough so as to prevent any collisions from happening. Out of these 16 satellites, 2 satellites will be used as pairs. Circular orbits are also used instead of inclined orbits, as the region of interest are near the equator. Next, I'll pass my time to Wei-Che.
Thank you, Aiman. The soil naturally emits microwave radiation that will be picked up by the soil moisture sensors in the satellite. This information is roughly translated into brightness temperature, ranging from 0 to 1. There are factors that actually affect these emitted signals. These factors are vegetation, soil surface roughness, as well as soil type. For example, vegetation makes the soil appear drier. Luckily, these factors have polarization values that can be taken into account. Finally, these microwave radiation have long wavelengths, hence they are able to penetrate deeper into the ground and gain more accurate information. I'll pass the time on to Singer.
Thank you, Wei-Che. Moving on, albedo sensor is a type of passive sensor that detects the natural energy emitted by the green vegetation that are being examined. The natural energy is also known as electromagnetic radiation emitted by the sun to the green vegetation and is absorbed as well as reflected by the chlorophyll. The absorbed radiation are mainly in red and blue wavelengths, while the reflected radiations are in green wavelengths. Furthermore, the internal structure of green leaves acts as an excellent reflector of near-infrared radiation. The reflected near-infrared radiation has a unique spectral reflectance, and deviation in this signature is detected by the albedo sensor. It could be an indication of potential forest fire. Now I'll pass the time to Kaiji.
Thank you, Singer. Now allow me to elaborate about the current problems and solution. Firstly, I'll be talking about multipath effect. So many of you may ask what multipath effect is. Basically, it happens when 2 or more different signal paths are received by the receiver. What causes it? It usually happens when there are high buildings or trees that are blocking the GPS signal, as you can see in the above pictures. My team and I have come up with this solution, which is to place our receiver at higher altitudes area where there will be lesser buildings and trees blocking the signal path. Secondly, it will be space debris. Space debris can be classified as space junk or any non-functional space object. The picture behind me shows how the space debris could affect the satellite. The debris would be moving at a very high speed, which could result in a collision with the satellite, causing it to malfunction. Since debris could be detected, we would be able to prevent the satellite from being damaged by maneuvering the satellite. Lastly, I will be talking to you guys about maintaining in line with the orbital plane. This is talking about the satellite maintaining the direction of motion in the orbit, as well as to ensure that there are no external forces which could affect the direction of motion. The picture above me shows what might happen if the satellite does not maintain in line in the orbital plane. This might lead to a collision. Our solution is simple. It is to use gas jet thrust to move the satellites to ensure that we are at the correct orbital plane. In addition, we have to ensure that the solar cells are pointing towards the sun. Now, I'll pass on my time to Terence. Terence, please.
Thank you, Kai-Chin. Now I'll describe to you our mission operation. There are 4 different phases: the launch early orbit phase, the commissioning phase, the routine phase, and the decommissioning phase. Now in the launch early orbit phase, the Satellite Control Center will take control of the satellite once the satellite is able to float itself independently in space. When the satellite is in space, it's hard for us to track its location. Hence, with the intercommunication link and the ground antenna, we'll be able to track the satellites accurately and also maneuver it to its required orbit. Next, in the commissioning phase, the satellite has to undergo several functional checks and tests to ensure that the satellite is free from technical glitches and bugs, which will not compromise our program. In the routine phase, we have to ensure the differences in distance will not grow over time, as this might lead to an inaccuracy of results. The maintenance then can be done by the satellite's own propulsive system. The reflected ray sensor and soil moisture sensor will detect the trees which are unhealthy or if there are lack of trees. The signal will then be sent to the ground station for further analysis. Lastly, in the decommissioning phase, the satellite will use its propulsive system to position itself at an angle towards Earth. During the re-entry, the high atmospheric drag will cause the satellite to burn up itself, hence it will be free from space debris. This is the finance report, and we'll be taking NASA's average small spacecraft mission as our example. Now I'd like to pass my time to Matthew for the conclusion. Thank you.
Thank you, Terence. In conclusion, the team feels that deforestation is a serious problem that is best tackled by using the satellite constellation. Specifically, the passive albedo and soil moisture sensors will be used to detect these signs of deforestation. This presentation has also covered some problems and solutions with using the satellite constellation, and it has to be noted that mission operations needs to be specially suited for this satellite constellation. With all the benefits, the team hopes to see this solution being implemented in the future. Thank you.